All right, welcome. So let me kick it off. My name is Zuhair Ahmed. I'm a senior product manager at MongoDB, and today we're here to talk about the MongoDB Atlas Terraform provider. Super excited to share some updates, some roadmap items, and then towards the end we actually have a demo prepared. So on this webinar, everyone here will be able to, or at least the hope is, everyone here will be able to deploy their very first MongoDB Atlas cluster. We'll be deploying an M0 or a free tier cluster, so no credit card or any expenses are required. Again, super excited to kick this off. But first, a few housekeeping rules. One, the webinar will be recorded and shared. I am told that this is being streamed live on YouTube, so welcome to everyone on YouTube. All participants will be muted. However, you're welcome to use the chat. Please use the QA box for questions. For live comments, use the chat in your control panel. And there will be a short survey at the end. Please take a moment to fill this out. If at any point you feel that this webinar is going great, you're welcome to jump in early and provide comments, or conversely, if you feel that Zuhair is a terrible host on a webinar, feel free to share that as well. We love your feedback, both positive or negative. Okay, so the agenda. Going to spend a little bit of time. I'm sure the folks who are dialing in are somewhat familiar with infrastructure as code, but just to level set, wanted to talk a little bit about what is DevOps, what is infrastructure as code, where does Terraform fit into this landscape. Quick introduction into some key tools that we're using, mainly MongoDB Atlas, HashiCorp Terraform. Want to dive a little bit into the internals. How does the MongoDB Atlas Terraform provider work? What are some of the mechanics beneath it? And then a demo and some information on where to learn more. If all that makes sense, let's get started. Okay, so IaC, or infrastructure as code, within the DevOps landscape. Okay, now there are a lot of tools here, right? I mean, you can think of DevOps more broadly as that bridge between developers and operations, and you have all sorts of aspects of that software development lifecycle, everything from continuous integration, delivery. You have different tools in build, test, deploy, and run. The focus of this talk is going to be right where that red circle is. We're going to be focusing on the deployment section. Terraform, HashiCorp is almost like the 800-pound gorilla in the room. We'll be talking a lot about that particularly, but just quick highlight. It is a infrastructure as code tool. It was launched in about 2014, and it is multi-cloud and open source, which are two key aspects why folks love to see that adoption very quickly. Another one which we also support, and we launch integrations for, we went GA for with MongoDB Atlas, is AWS CloudFormation. That is a native infrastructure as code tool that is native to AWS. So for folks who are either all in on AWS or looking for a tight integration with Amazon Web Services, there's that AWS CloudFormation tool there. And then just the last thing I want to highlight on this slide is people think about Terraform and CloudFormation as infrastructure provisioning tools. So this is the point where you're actually deploying VMs into the cloud, deploying Atlas clusters and IP access lists and other infrastructure. Again, all the real value for a lot of these tools is the fact that they have registries, and you can deploy not just Atlas, but you can deploy different services from the different cloud vendors, so including Azure and GCP. You could think of like Cloudflare. You could think of Datadog. There's a whole host of different components out there. And my goal one day, hopefully, is as the community begins to grow and begin to scale, is to see lots and lots more APIs. If you have an API out there, it hopefully should be up on the Terraform registry, so folks can use that within infrastructure as code. That is often compared against the configuration management tools. These tend to be a little bit more legacy. You can think of Chef, you can think of Puppet, you can think of Ansible. So with the configuration management tools, and more broadly, they tend to help manage the software within the server, whereas the infrastructure provisioning tools like Terraform and CloudFormation help to manage the actual deployment of those servers or of those VMs directly. Hopefully that helps at a high level. Why use infrastructure as code tools? This can be part of like a business justification if you're part of an organization. First and foremost, some of the business reasons: automation. So with IaC tools, you get repeatable, consistent, and reliable infrastructure deployments. So a good example here is that you spend some time, spinning up some resources within AWS. You click in the UI management console. to now replicate, let's say you spin up like an S3 bucket, you have a few EC2 instances, you set up your networking, you have your VPC, your virtual private cloud. To do that 10 times, to do that 100 times is very difficult at scale. To have exactly the same parameters and exactly the same preferences that you've created the first time around, the second time, especially now when you're working with teams across the world, different teams within your organization, it's very difficult to actually clone those environments. With IaC tools like Terraform, like CloudFormation, you're able to do that pretty seamlessly. You have your infrastructure as code. Terraform, it uses HCL primarily, HashiCorp configuration language. CloudFormation tends to use YAML or JSON files, and you're able to get that benefits of automation. You can also fit Terraform into your CI/CD pipelines. So you can think of like having like a tool like Jenkins has like certain automated tests within there. So you can making sure that your code before you push it out to production or any kind of changes you have in your Terraform code, make sure to pass those tests correctly, whether it's unit tests or acceptance tests or other types of tests, build tests that you're doing within your organization. Another key benefit is version control. So you're already checking in your source code into like GitHub or any kind of infrastructure, any kind of source code repository like Bitbucket. Why not also check in your infrastructure provisioning, infrastructure code as well? Right. So the same benefits as you get for team collaboration, from transparency, like, do you really need to use an M300 cluster for your deployment, or are you okay with M10, for example? Right. You have that ability to actually manage what resources are being deployed, and you're very transparent upon it. And then if you make changes, let's say you add a new cluster to a different region, you can actually revert back, to any of those changes, or you can understand that who made what change when. This is a big one for security. You have a clear audit trail for each infrastructure modification that you're making, right? And maybe you want to be a little bit more fine-grained, and you want to have certain teams within your organization have certain set of deployment permissions, and other teams have other set of deployment permissions, so like kind of guardrails for your development team. Well, stuff like that is something you can do with Terraform. Disaster recovery. So, once in a while, cloud regions goes down, in AWS US East 1, unfortunately, this happens every once in a while. So you can now, you can have like monitoring tools like Datadog, for example, and you can detect when a region goes down. You can spin up that exact same, environment in minutes. So your application is more resilient in the event of a disaster or cloud region outage. And then last but not least, cost savings. There is a real cost to deploying some of these resources, whether it's your MongoDB Atlas bill or whether it's other vendors, whether it's AWS, Azure, any type of third-party service. So you want to make sure to have that transparency. You can actually, if you're over-provisioned or under-provisioned, you can have that. And then just the last thing I want to mention is that these are actual, resources in a data center somewhere, right? And primarily one of the hyperscalers or one of the cloud vendors. So by reducing your cloud spend, more often than not, you're actually goes hand in hand with reducing your carbon footprint as well. So you're both lowering your costs as well as lowering your carbon footprint by optimizing your cloud resources. So hopefully that makes sense. So we've been talking a lot about MongoDB Atlas. What is MongoDB Atlas? So MongoDB Atlas is a developer data platform that extends beyond the fully managed capabilities of just MongoDB to address your data requirements for building modern applications, right? And MongoDB, of course, is already the best place to go for the document model. We have a whole host of resources out there. We think that developers tend to think in JSON. So when you actually comes to your database layer, you want to have something that's really easy, really transparent. So MongoDB is the largest and most commonly used document database. And then if you were going to go to like a search engine rankings, for example, like DB engines, for example, we're #1 most commonly used within the NoSQL database market segment as well. So super excited to share all those details. But the problem with using it, not just MongoDB, but any kind of database, is you have to think about like scaling, you have to think about sharding, you have to think about backups. Why do all that undifferentiated heavy lifting, right? So the main benefit of Atlas in particular is that you get to remove all those headaches, right? So with Atlas, we take care of, MongoDB itself takes care of a lot of the scaling issues when it comes to having a fully managed multi-cloud database, right? And this is, I think, a point that is missed on a lot of customers is like, you could use a particular database on any other dedicated cloud region or cloud provider, for example. But with Atlas, you get the real benefit of multi-cloud. So you can actually spin up a MongoDB Atlas cluster with one node sitting in AWS and another node sitting in Azure, another node sitting in GCP, for example. So even if that region goes down in that cloud provider, you can have your backups or spin up your databases in that other cloud region. So you actually tend to have more nines of availability than any one cloud vendor have. You can take the best of all cloud vendors, or take the tools, or if you're primarily running AWS, but you like the machine learning capabilities of GCP, for example, you get that benefit with Atlas. You get the best of both worlds with taking advantage of that multi-cloud framework. In addition, with Atlas, you get some kind of search and analytic capabilities. With Atlas Search, Data Federation, Atlas Charts, Data Lakes. You have application services, the Atlas Admin API, with triggers, functions, data APIs, user authentication, and then just last but not least, with Atlas, you also get integrations into other applications as well. So the focus of this talk is on Terraform, but just to highlight, we also have MongoDB Atlas integrations with Kubernetes. We have an Atlas Kubernetes operator. We have integrations with CloudFormation for customers that prefer to use that framework. We recently, earlier this year, which we'll talk a little bit on the presentation, we recently launched integrations with CDK, or the Cloud Development Kit, both natively with AWS CDK as well as CDKTF, CDK for Terraform, and that effectively launches, integrates MongoDB Atlas with natively in the language of your choice. So if you prefer, if you're a Java developer, if you're a Python developer, if you're a Go developer, and you want to stay in that world, well, great. Now you don't need to worry about managing, HCL or Terraform config files. You can launch your Terraform directly in the language of your choice with CDKTF. So super excited about all those updates. Okay, so MongoDB Atlas is awesome. I want to highlight that, at least my humble opinion, HashiCorp Terraform is awesome. And you don't have to take, my point of view from it. This is an interesting survey from JetBrains, and this is a developer survey recently, 2022, and they basically asked, what infrastructure provisioning tool do you or your organization use? All right, and the most commonly used infrastructure provisioning tool, at least according to the survey, was Terraform, with about 37% of respondents. You'll see some other commonly used tools here that we talked about, particularly CloudFormation and CDK. But this really tends to be the 800-pound gorilla in the room, as I mentioned. Terraform is awesome, right? In addition to being multi-cloud, just similar, it has very similar ethos with MongoDB Atlas. You create your Terraform config files and deploy to, you have full registry, with both Azure and GCP, as well as a growing number of different providers out there. It's also open source, just like MongoDB. So if you ever are concerned, or if you ever are unsure about whether to deploy things, or you're worried about like some kind of security parameters or infrastructure, you can actually review Terraform open source's source code, which is kind of cool. And the same goes for Vault, same goes for a few other HashiCorp tools out there. What is HashiCorp? HashiCorp itself is a key partner to MongoDB, as well as to each of the cloud providers. As of late, they have just crossed over 3,600 customers, 415 global 2,000 customers, about 180 Fortune 500 customers. Within the infrastructure space, our talk is going to be focusing primarily on Terraform, but there are a host of other tools that we encourage other folks to look into. Primarily on the security side with Vault, there is also a MongoDB Atlas integration with Vault. We have two database engines, both for IP access keys as well as for database users. So feel free to check that out as well. We may have more webinars or more blog posts highlighting that integration. And that HashiCorp Vault integration with MongoDB Atlas is also 100% free and open source. We use the Mozilla public license, Mozilla 2.0 public license. So anything that we do on this webinar is going to be 100% free. Most of the development that we do on my team is 100% free and open source. So there's no cost to users to use. The only cost that you will incur is the actual Atlas consumption they use, but the tools themselves are 100% free. Okay, so we talked about MongoDB Atlas is awesome. We talked about HashiCorp Terraform is awesome. The big registry, you have lots of different providers. You have access to, make all your deployment in a consistent language and framework. How can we make them together, right? And so a few years back, we thought about this problem, and we launched the MongoDB Atlas Terraform provider. This first launched in 2019. We've been seeing an uptick in usage over the past few years. All the links for the resources are going to be shared within at the end, and we have a slide dedicated to links. But just for what it's worth, I do definitely want to highlight where you can go to see our provider, right? It's going to be registry.terraform.io. And all you have to do is just search MongoDB Atlas. It's the first one that comes up. So super excited to share that. We've crossed over 14 million downloads over all time. This provider, the MongoDB Atlas provider, is the #1 most downloaded provider in the database category, and we're in the top 10 overall by downloads in the overall Terraform registry. So you could think of like all the different providers out there, all the different categories. MongoDB Atlas is within the top 10. So we're super excited to share that, and thank you for all the hard work and partnership with each of our customers. So I'm going to go back to our presentation. Okay. So hopefully all that makes sense. Again, feel free to leave questions in the Q&A chat room. We have time at the end to go through all the questions. I now want to pivot a little bit and just look a little peek under the hood, or a little bit under the bonnet, wherever folks are around the world. How does the Terraform Atlas provider work? Where does it fit into the overall landscape? And this, I think, is actually kind of fun. This is actually my favorite slide in the entire presentation. This is, and it really all comes back to one word, which is abstraction. Right? At the heart of everything that we do is the MongoDB Atlas admin API. Right at the very top, and the Atlas Admin API is a RESTful API. You can think of that as a control plane for MongoDB Atlas. So this is the management layer. So it allows you to spin up clusters. It allows you to create database users, IP access lists. You can manage your programmatic API keys. We can now programmatically create organizations. A whole host of all the administrative things. The main thing you can't do is the data plane. That's separate, right? So the Atlas Admin API helps you set up the clusters, but it doesn't have access to the data within the clusters themselves. For that, you can use the Mongo shell, or you can use Data API, or a few other hosts of MongoDB Compass, a few different ways of actually accessing the data plane itself. The whole purpose of this talk and the Atlas Admin API is the control plane, or the management layer. Now, the main issue with the Atlas Admin API is it's great for machines, but it's difficult for humans to use. If you wanted to call or spin up, let's say you wanted to spin up a database cluster, you have to create a curl command, which is very manual. You have to create a very extensive scripts, which tend to be very difficult to scale. So based off customer demand, we launched the Atlas Go HTTP client, and then just at MongoDB .local last month, we announced the GA of the Go SDK. So effectively, what this is a layer of abstraction that sits on top of the Atlas Admin API. And for Go developers, you no longer have to worry about writing all those HTTP put, get, patch methods anymore. All the HTTP client stuff is handled for you directly, and this is great. For what it's worth, the downstream tools are mainly written in the Go language, in Golang, and you can again see that these are all open source tools. So now that we have a common layer at the Go client, we then built up the Atlas Kubernetes operator, we built up the Terraform provider, we built up the CloudFormation resources, and we built up the Atlas CLI. Those are all layers of abstraction that are built on top of the Go client, which are then built on top of the Atlas Admin API. Now, the last thing I want to say, and again, this is why it's so cool to be a developer in 2023, is with CDKTF, right? So let's say you're really excited about Terraform, and you want to get started, and you jumped on this webinar, and you're ready to go on MongoDB Atlas. Wonderful, we're happy to have you. CDKTF is a layer of abstraction on top of Terraform, which then allows you to deploy natively, as I mentioned before, in your language of choice, right? So whether it's Java, Python, Go, C#. right? So you deploy an Atlas cluster in CDKTF. That is a layer of abstraction that gets synthesized down to Terraform code, HCL. That then gets synthesized down into our Go client, and then that gets synthesized down to an Atlas admin API. So you're looking at like 4 layers of abstraction by using CDKTF, or 3 if you just use a Terraform provider directly. So I find that to be really, really fascinating. You know, and you know, you have all these tools that hopefully make your life easier and allow you to do what you do best, which is to start your next great business, or your next great company, or your next great application. You focus on your users, and you leave that, again, that undifferentiated hefting, the undifferentiated heavy lifting, the database administration management to MongoDB, and hopefully you do well within your focus. So hopefully that helps. I already mentioned that, you know, we're number 1 in the database category, in the top 10 overall within the Terraform public registry. There are lots of resources out there comparing Terraform to CloudFormation, so I don't want to spend too much time on this. The main takeaway I want you guys to have is that there is a dedicated language called HCL. I've mentioned a few times before, HashiCorp configuration language. I love HCL. I think it's really easy and really intuitive to learn. But if you've been working in YAML or JSON for a long time and you love your configuration language, it's a little bit of a learning curve, right? There's a little bit of to figure out all the different commands and what you can and cannot do. But it is managed by Terraform. It is something that is also open source. You can check out the repo on GitHub, or contribute to it if you like. So with having the main benefit of having a dedicated domain-specific language like HCL is that you get to optimize that for your use case, which in this case is infrastructure provisioning. Whereas YAML or JSON are more general-purpose scripting languages. So that's one of the benefits of using Terraform. With CloudFormation, you're only stuck with just JSON and YAML. The other thing to keep in mind is Terraform is multi-cloud, right? So again, you can deploy a whole host of different vendors on the registry, including AWS, Azure, and GCP. CloudFormation is a first-party AWS tool, so you can primarily only deploy to AWS Cloud. So again, if you're looking for that tight integration with AWS, awesome, use CloudFormation. If you want to go to multi-cloud, which I suspect where most of the folks who are on this Terraform specific call are more interested in, go with Terraform. Our Terraform provider overall, you know, because of the overall Terraform ecosystem is a lot larger than CloudFormation, sees a lot more traffic than our CloudFormation integration. And then just the last thing I want to highlight before we jump into the demo is CDKTF. This is something that we only went GA earlier this year in February of 2023, but already we've been seeing, you know, high growth and high demand here. We're super excited to help enable customers succeed and grow within Atlas wherever they are. Part of the ethos of MongoDB is meeting developers where they are, right? So if you are a seasoned Java developer, you love Maven, you know, you've been in the ecosystem for 10, 15 years, great. We don't want you to waste your time, you know, or getting a PhD in YAML or dealing with all these configuration files or whatnot. We want you to stay in Java. You know, if you're a Java subject matter expert, you know, wonderful. With CDKTF, you can now use your Java skills to deploy Atlas clusters, to manage Atlas resources. And then the other benefit, which I also want to highlight, is these are Turing complete languages, right? Like Python, Java, C#, Go. So you get all the benefits of using loops and using like IDE integrations. If you like VS Code, for example, which is my IDE choice, you get syntax highlighting. All the benefits of using that Turing complete programming language you could now use for infrastructure and provisioning. So there's lots of cool things that you can do with CDKTF that you can't do with plain vanilla Terraform. So hopefully that helps. And then just from like a, you know, how it works structure standpoint, every time that we issue a release of the Terraform provider, which generally happens on a monthly basis, our CDKTF is automatically updated. So you never have to worry about a gap, whether like, hey, I'm really excited about using, you know, we recently launched support for MongoDB Atlas programmatic organizations. You know, and you love that new feature, wonderful. There's no real delay between Terraform and CDKTF. As soon as that issue drops on Terraform, within an hour or so, it's available on CDKTF. So super excited to provide that level feedback to our customers who enjoy using CDKTF. Okay, hopefully that helps. I know I've been doing a lot of talking, so feel free to jump in with any kind of Q&A or any kind of questions. Again, we have plenty of time to jump into the chat. But at this point, I want to pivot, and we've prepared a quick demo. Again, everything is being recorded. I believe this is live from YouTube Live, so you're welcome to go back and review this as possible. The one thing I do want to highlight before I jump in is we have a blog post, or something that I'm really happy when I joined MongoDB. About a year ago, we published a blog post on basically how to deploy Atlas with Terraform. The purpose of this talk and the purpose of this demo is effectively walking through this blog post as well. So if you're more of like a reading and writing learner, that's fine, versus like a tutorial type of things, go to this blog post, and it'll basically walk through each of the steps that we're going to be following here. Again, links will be included in the presentation and will be shared. If all that makes sense, let's get started. First thing I want folks to do, if you're brand new, to anything, is to create a MongoDB Atlas account. It is easy and it is free. No credit card is required. You can literally go to cloud.mongodb.com and you can create an account. I'm not going to go through that here. You basically have to input your email, you verify your email address, and you're off to the races. There's lots of different bells and whistles that once you have created an account, what you can do. But just to focus our talk today, once you have created that MongoDB Atlas account, and once you go into Access Manager, and you are going to see a screen like this. It's called Organizational Access Manager, and we are going to create our very first programmatic API keys. Now, when I say programmatic API keys, everything that we do with the Atlas Admin API or Terraform is effectively our programmatic usage, right? So you need to have API keys that basically tell Terraform that, yes, these are authorized transactions. Everything is valid to what I'm doing, and you're being linked to a specific Atlas organization. Atlas organization is that parent organization which helps manage all the users. So we're going to be creating our organizational programmatic API keys, right now. So if you're looking at my screen, you're at this window. You'll see this button, Create API Key, at the top right. Let's click that button. I'm going to make a quick description. I'm going to call this Test 3. You can see all the definitions of organization permissions on the right-hand side. Typically, best security practices that you want to use least privilege access. For our purposes, though, we're going to make this organizational owner, which is the highest. Again, for demo purposes, this typically you want to be for admin purposes. But again, for demo purposes, we're going to be giving yourself organizational permissions. And with one click, you've created your API keys. So congratulations. What I like to do is I open up like a blank text file just to make sure I don't lose these keys. These are secrets. Right, so you want to keep these confidential. Just FYI, all the secrets you see on the screen now will be deleted right after the webcast, so no worries there. But you want to make sure to save these down in a secure location. So I am going to save them into our text file. So once I leave this key, you will only see your private key once. So this is the only time you can see your private key. Once you leave this window, it's very similar to the AWS management console, if you're familiar, creating public key and private keys there. The other thing that I want you to do is while you're here, there's a button at the bottom that says API Access List. In order to use these programmatic API keys as an additional layer of security, MongoDB Atlas requires users to add their IP address. Now, you could make this open to everyone, 0.0.0/1 for the first half of your recital range, and then 128.0.0.0/1. However, what I like to do is there's a helpful button here that says use your current IP address. So I click that and then click Save. And with that, you're done. All right, you've created your API keys and you've said the terminal that you're using or the computer that you're using to actually deploy your MongoDB Atlas environment. You can do that with one click of a button. So hopefully that helps. That is more or less it. And just to show you, if I go to my Access Manager and I go to my API keys, and I look at the one that I just created, test 3, you see the private key is starred out. So you will never be able to, even if you call MongoDB Atlas support, we'll never be able to retrieve your private key. So that is the one and only time you have to take a look at it. So it's very important that you save it down. But what you can do is you can always add IP access, your IP access list. So if you ever wanted to add a different CIDR range or delete this one, you're more than welcome to do that. It's just that private key which is redacted. If all that makes sense, let's jump over to the Terraform side on the left-hand side of the screen. And effectively, what I did before this talk is I just created an empty directory. By the way, I'm in an Ubuntu environment in Linux. You're welcome to follow along. You will also, you'll have to make sure that you install Terraform onto your machine. Steps are really easy. If you go back to the blog post that I mentioned earlier, we just finished step 3. You created your IP access list. Step 4 is actually setting up billing if you want to use any kind of paid tier offerings, which we're not doing. Everything we're doing here is free as part of this webinar. Step 5 is install Terraform. Really easy. Again, I'm not going to do that because I already have Terraform installed on my Ubuntu machine, but you can follow the steps. You just go to the Terraform documentation, click install, follow the details that make sense for your machine. Okay, once you've done that, step 6 is actually setting up your environment variables. What we're going to be doing is, just for convenience, is we're going to be hard coding our API key secrets into our main.tf file. This is not recommended best practice, but I do find it helpful for webinar purposes. What you want to do typically is that you would open your terminal window and you would create these 2 export variables, MongoDB Atlas public key and MongoDB Atlas private key. And effectively what that's doing is Terraform is saying, hey, the secret to access your IP keys is part of your environment variable. Go there first. So this way you're not exposing sensitive secrets. But again, just for convenience, we're going to copy paste our secrets into here. Great. And again, templates for these are all found on our repo. If you haven't been there yet, it's just github.com/MongoDB/Terraform-provider-MongoDB Atlas. As mentioned, this is free and open source. This is exactly where I got the starter example from. So basically, you would create a provider block within HCL, and you would insert your public key, private key. Great. You just make sure to save every once in a while. Above that, I have what's called a versioning block, and basically, I'm basically telling Terraform to download the latest version. We recently launched, I believe it's 10.2. If I go to MongoDB Atlas, and you can see, yep, 1.10.2 was published 7 days ago, and effectively, by not specifying the version number, I'm telling Terraform to download the latest version, which is usually appropriate for most cases. You can put the version in here if you wanted to be specific. For example, and use 1.10.2, for example. I'm not going to do that, just so it's always on the latest and greatest. And then the required version is for the version of Terraform itself. We just require that use above 0.13. Okay. Next, we're going to create 4 resources within Terraform. And this you're going to use in almost every Atlas deployment. You're going to be creating a MongoDB Atlas project. We're going to be creating a MongoDB Atlas database IP access list, or a project IP access list. We're going to be creating a database user, is 3. And then 4 is our cluster. We call in Terraform script, you may have seen the word advanced cluster. That's our verbiage for multi-cloud cluster. So if you ever did want to, we're just going to be deploying on AWS today, but if you ever did want to modify this to run on AWS and Azure and GCP, for example, you're welcome to explore and try that as well. All the examples are on our documentation as well as on our GitHub repo. But just to jump right in, the first thing we're going to do is we're going to create a project. So this is, you can think of as the initial shell, and you can call this whatever you want. And again, what I like to do is I like to go back and forth in the documentation. So I look at MongoDB Atlas project, and I can see there's a good example usage here, which is awesome. And then it actually tells you in the documentation what's required. So you can see a name and org ID is required. So effectively on the left-hand side screen, you can see that I have my name and org ID already inputted. I decided to call this project test cluster. just for what it's worth, let's change the name to test cluster 2. And the org ID you can actually find within the Atlas UI. Let me show you that real quick. Once you're in your UI or user interface, you can click on this gear icon, and you'll get your organizational ID over there. So there's a button to just copy paste, and I can paste that into my Terraform config file. Okay, so we just created the script for our project. Let's move on to the database IP access list. Within any given project, for example, on the left-hand side of the screen, again, I'm in the Atlas UI, you're going to see under security database access. This is basically saying, as an additional layer of security, what's the username and password to access that MongoDB Atlas cluster that we're about to create, right? The resource is called MongoDB Atlas database user. I've given the name db-user. You can call the username, password, whatever you want. I decided to call it user-1. Password is test password. What's really cool about HCL and Terraform more broadly is I love the syntax. It's very intuitive. So for example, I needed a project ID. So what I did is I went back up to this other resource. It's called MongoDB Atlas _project. And all I did was, and I have Code Guru and a few other aspects installed, or GitHub Copilot. So it's going to pre-populate for me. And this is one of the benefits of using, VS Code. But effectively, all I'm going to do is do .project.id. And that's going to give me the project ID that I need for this database user. Again, these are the basic required parameters. There's a few others. If you go to our documentation, you can modify however you think best. The database name I'm going to be calling the auth database name. I'm going to be calling admin, and the roles I'm going to give myself read-write permissions for the database name of test cluster DB. Okay, so that's 2 resources down. The third resource we're going to be creating is called a database IP access list. So similar to like database user, there's a tab here under security that says network access, and this basically lists out all the different IP addresses that are allowed to access your MongoDB Atlas cluster. Similar to before, project ID is able to dynamically grab the project ID without hard coding it in. The IP address I am hard coding in because that's my own personal IP address. You can, again, if you're ever confused, you can just go right back up to Access Manager. You can go to API keys. You can go into your actions, edit permissions. Let me go into next, and you can always get your own IP address by clicking this button, use current IP address. So I took that 50.89.69.57 and I just pasted it in there. So that's good. Okay, so that's 3 down. And fourth, and most importantly, is the Atlas cluster itself. Okay, so this is a MongoDB Atlas Advanced cluster. I've given the name of Atlas-cluster. Project ID I'm dynamically creating. The name, I decided to call it my first cluster, and let's change the name to my first cluster 2, just for what it's worth. Cluster type is replica set. Under replication specs, and again, if you go to our documentation, you can see more detail. Just for time purposes, I'm going a little fast, so I can get time to get to your Q&A. But if you go to our documentation, you can actually see each one of these parameters, what they mean, use cases, how to modify. Let's say you want to go to M10 or M20 or M30 clusters, you can do that. For here, we're just using M0, which is our free tier cluster. We're deploying within AWS, which is the backer provider name. We're deploying within a specific region within AWS, which is US East 1, which is in Northern Virginia. And we're giving ourselves a priority 1 parameter for the cluster. And that's really it. That's the basic scripts you need to actually create your very first MongoDB Atlas deployment. Project, IP access list, database user, and advanced cluster. What I'm also going to be doing is I'm going to walk you through optional outputs to display. So if you want to stay in your Terraform environment, for example, I have the example here to output my connection string. So if I ever want to use MongoDB Compass, which actually I think we can do in this demo, it will output my connection string. If I want to use the output the IP access list, what IP addresses can access that database, then awesome, I can output that. Project name, user and database username, database user password, which is a sensitive secret. I'll show you how to access that, is all being outputted. Again, and now you don't have to memorize any of this stuff. All this is available on a GitHub repo under starter examples. But I did want to walk you through that. Hopefully that makes sense from an HCL standpoint. Now this is the fun part. Let's open the terminal. Let's hope the demo gods are with us today, and let's see if we can actually deploy. The very first thing you want to do, again, I only have one file in here so far, which is main.tf. The very first command I'm going to show you is Terraform init. You want to init is basically initializing your Terraform environment, and you can see that it's grabbing our latest version of the provider, which is 10.2, which is awesome. It looks like Terraform has been successfully initialized, which is awesome. And if I look into my folder structure, I see that I have a bunch of files that have been pre-populated here. You can look at our changelog, you can look at our licensing, you can look at a lock.hcl file. So all that seems to be good. Okay, so that's the first command. The next command is Terraform apply. Actually, before we do that, my favorite command, I almost forgot, is Terraform plan. Terraform plan is purely a check. It doesn't actually output or doesn't create anything, but what I found is super helpful, and it's helped me caught many bugs in the past, is that it creates a plan of the proposed infrastructure changes that you're looking to do. So for example, I hit Terraform plan, and it's showing me Terraform will perform the following actions. It's one, going to be creating an advanced cluster, which is good. That's what we want. And all the specs, it looks like it's being created in AWS. It looks like it's being created in US East 1, which is good. 2, it's creating a database user, which is awesome. It's creating a project, which is awesome. And it's creating a project IP access list. So it's the plan for this Terraform config file is to add 4 resources, 0 changes, and 0 to destroy. As you get more creative within your Terraform journey, you will have lots of things. And this is actually a really good check with the Terraform plan. If you know that you're only creating 4 resources, but something is being modified in here, something is being destroyed, well, then you made an error or there's some other error within your script. So it's a good way to catch that. And it also highlights your outputs. This looks good to me. So let's move on to Terraform plan. I'm sorry, Terraform apply, which is the third command. Now this will also show you what the apply is, right? It's going to basically do a repeat of the 4 resources to add, 0 to change, 0 to destroy. But this time it has an additional prompt. It says, do you want to perform these actions? Only yes will be accepted to approve. So you can put anything you want, but only yes is going to be accepted. So let's hit yes, and let's hope that this deploys. Again, we can cross our fingers and toes, and hopefully our demo god's with us to take a look at this. But looks like so far everything seems to be going well. Just looking at the terminal. Project IP access list is being created, advanced clusters being created. Looks like some of these resources have already been created. The M0 clusters, again, if you're creating it for the very first time, typically takes a few minutes. So I'll go back and forth just to show you while this is spinning up how this is looking like in the UI. I'm going to hit refresh on the screen, and let's see. We called our project. Let's see if we can remember correctly, test cluster 2. And if I look on the UI, it looks like this new project here called test cluster 2, which is awesome. And I'm going to jump into that test cluster 2, and it looks like already it has this M0 cluster, which again is a free tier cluster, which is being populated, which is being created, which is awesome. So that's 2. I'm going to database access. I have a database user called user1, which has already been created, which is awesome. That's 3. And if I go to network access, it looks like my IP address is here. That's 4. That's 4 for 4, which is awesome. The only thing I do want to do is I want to give this a few minutes to actually populate, and you can make sure that I'm not being a liar and it's actually going to be created here live for you. So let's see, it's been about 1 minute and 20 seconds. What I love about our Terraform provider is that every 10 seconds it gives you an update, so you can actually know where it is in this journey. While that's loading, I think it's going to take maybe about another minute or so. Let's jump over to our GitHub again, which is MongoDB/Terraform-provider-MongoDB Atlas, and let's take a quick peek into our changelog. Our changelog is a good resource to look into in general, and it helps you find some of the recent updates that we've released. Pro tip is that anything at the far right of our versioning, this is 10.2, 10.1, are minor releases, and then the middle number, whether we do like 1.9, 1.8, 1.7, those are what we consider major releases, and those are the ones that are currently going to have like big updates to take a look at. But the minors are also really good for like documentation updates or bug fixes. What I'm very proud of is that within our GitHub repo, we're very quick at closing out issues or pull requests. So even if you're not a paid MongoDB Atlas user, if you run into any issues or if you have an issue with your deployment, feel free to create a GitHub issue. Someone should be able to respond with you pretty quickly. So you're never alone in this journey. But just to highlight, if I look at v1.10, we announced support for programmatically creating organizations, which is really cool. So before then, you had to go into the Atlas UI or Atlas Admin API to actually create the organizations. Now you can do all that through Terraform. We announced support for federated database instances, which is really cool. So if you want to looking to offload some of your instances, for cost reasons or for security reasons to like an S3 bucket, for example, you can do that. Or if you want to create query limits, across your entire infrastructure, you can do that now. Again, while staying in Terraform. We announced support for cluster outage simulation. If you just want to test to see if your cluster is going down or not, you can do that via Terraform. Yeah, I think those are some of the big ones. In v1.9, we announced support for backup compliance policy, which is really cool. So if you're looking from especially if you're a big customer, a big financial service customer, you're looking to have, no one destroy a cluster, or you want to make sure that it's locked down, you can do that now with Terraform. Okay, good. Looking back on the left-hand side, it looks like this Terraform deployment was successful, apply complete, 4 resources were added. And if I go quickly back into our terminal, I'm going to just hit refresh our Atlas UI. It looks like this M0 cluster is up and running. So congratulations, everyone. You have just deployed your very first MongoDB Atlas cluster. And if you look down in your terminal window, you can actually see all the IP access list. These are outputs, Terraform outputs. You can see the name of your project name, username, user password. I mentioned to you that this is a sensitive secret user password, so just be mindful. If you do want to know what that password is, again, this blog post has all the helpful commands. You can do Terraform output -JSON, and then the name of the variable, which in this case is user_password. And then here it will show you in clear text, which is test password. Conversely, if you don't want to do that, secrets are stored in clear text in your state file, in your Terraform.state file. So you can always go in there and you can actually see some of the values for your variables, and database username and passwords are there as well. So hopefully that helps. The very last thing I want to just demonstrate before we go into Q&A is a very dangerous command, which is called Terraform destroy. This will spin down your entire environment. So if you want to, you're done with the application, you're done with your AWS environment or Azure environment, you hit Terraform destroy and then enter. It should prompt you again just to make sure that, yeah, exactly. You hit yes, and then we'll actually tear down your entire infrastructure. So you can spin up your resources very quickly with Terraform, and you can spin down your resources very quickly with Terraform. But just be mindful that this will destroy everything. So hopefully that helps. We have about 10 minutes left, so I'm gonna jump right back into the presentation, and I want to get to Q&A. Okay. Okay, so thank you for participating in the demo. Again, so there's a few links here. My colleague Mia and the rest of the MongoDB team will share some of these links after the broadcast. I'll now pass it off to Mia to share some words on MongoDB.local.
Thank you so much, Zuhair, for your amazing presentation. Thank you all for joining. I'm going to launch our poll right now. Please take a moment to fill this out. And while you are filling out the poll, I'm going to jump into .local. Before we get to Q&A, I want to invite you to attend one of our .local events, which might be coming to a city near you. Our next 3 will be in Chicago, Sydney, and Tel Aviv. When you attend, you will have the chance to meet with peers from this webinar with you, along with experts like Zuhair. Make sure to visit mongodb.com/local to learn more. When you register, enter code webinar50 to save 50%. Please make sure you are filling out the poll questions and let us know, give us feedback on how Zuhair did in this webinar today. Feedback will go towards future webinars that we do. I see a question in the chat. Please make sure you are putting those questions in the QA panel where Zuhair will see them and he can answer them live for you. And please make sure you are filling out this poll while we are going through Q&A. Going to hand this back over to Zuhair. Thank you again for the amazing presentation.
Cool. Thank you, Mia. I was actually at, the privilege of attending NYC.local last month, New York City. .local, strongly recommend it. Wherever you are in your MongoDB journey, we have lots and lots of resources there to connect and meet with your peers and as well as to learn more. So just jumping over to the Q&A, I see we have a few questions. Ben writes, we are currently managing our clusters, projects, and VPC peering in Terraform Cloud. Awesome. I love Terraform Cloud versus the open source Terraform. I know that Terraform is not really intended for data management, but are there any plans to add resources to create collections and indexes? We can create search indexes through Terraform, but not general indexes. Great question. The short answer is not in the near term. This is something that we do get asked every once in a while, but we are looking to make this experience easier in the long term. Effectively, MongoDB Atlas, the Terraform integration works off that control plane. So we don't have access to the underlying collections and databases for privacy reasons, for security reasons. We separated that control plane and that database plane. So Terraform can't can't create collections and indexes directly yet. But hopefully one day we can make that experience a little bit easier. But as of right now, you're correct. You won't be able to create those collections and databases through Terraform. Joshua asks, is it like planet scale for Mongo? One day. We'd love to get to the planet scale. I think, and Mia or Rituja or other folks can correct me if I'm wrong, but we're in about 110 regions. Worldwide. So all 3 of the major cloud vendors, there's AWS, Azure, or GCP, are supported. And as soon, I shouldn't say as soon, but pretty quickly, once a region is up, MongoDB Atlas tries to be there as well. We're very mindful of giving access customers to that region. So for example, we recently announced support for in AWS. We recently announced support for MongoDB Atlas in the UAE. Switzerland, there was a new region in India and Hyderabad, in Australia in Melbourne, and there was a 5th one, Spain. So if you're in any one of those regions, you can now use MongoDB Atlas with a little bit lower latency. So we're super excited to share that. Thanks for the question, Joshua. Charles Chillers asked, just curious on the advanced cluster, you mentioned its backing providers AWS. Does it mean everything is run on AWS infrastructure and not Mongo/Atlas infrastructure? So this is a little bit of a nuance. Advanced cluster, think of that as a superset of cluster, right? So cluster, you're typically restricted to just deploying into one cloud vendor, whether it's AWS, Azure, or Google. With advanced cluster, you have that ability to multi-cloud. But in the example that we walked through today as part of the demo, we only went through AWS, and you're correct because it's M0. We use the backing provider of AWS. MongoDB Atlas is that intelligent layer that's built on top of each of the different cloud providers. So under the hood, everything is being deployed and run on AWS. But to use Atlas and to use the benefits of scaling and integrations and Atlas search and charts, it's extremely difficult to do that and manage it yourself. So you could do everything via MongoDB Community Edition, for example, and you could do everything in AWS, though you won't have access to the developer data platform. You're more than welcome to try. It is a lot of work, With Atlas in particular, with using that M0 cluster that we demonstrated, you can get up and running in minutes, especially if you're using a tool like Terraform. And you can, again, focus on what you do best, which is building your application business and not worry about that infrastructure management. So hopefully that helps. I don't see any other questions. I think we have another few minutes left, so maybe I can give another minute or two for folks to ask questions. Just as a quick reminder, there is a poll, so feel free to fill out that poll. And I can give it another minute or two for the webinar in case of any other questions.
Yep, in case any other questions, we'll keep this open for another minute or so. Zubair is here to answer your live questions. And once this webinar ends, we will be sure to direct you to our MongoDB community forum if for any other questions that don't get answered in the webinar today. So we'll give it a minute. And Zuhair, if you have anything else you'd like to add from your presentation, more than welcome to.
Sure. I guess maybe while we're waiting, the only one last thing I do want to highlight is we spent a lot of time on documentation. So if you do have any issues, the best place to go is registry.terraform.io /provider/MongoDB Atlas, and click on the documentation tab. Each of the resources that we worked on together. So I think one of the questions from Charles was on advanced cluster usage. So you can actually you can click on it, or you can just type it in advanced cluster, and you'll get all the parameters that you need. And what's really cool, like especially if you're using like VS Code and you have like GitHub Copilot, we have so many users now that are using VS Code with our provider, and everything, of course, as I mentioned, is open source. It will actually fill in, it will autocomplete a lot of the parameters and stuff. So if you're creating an advanced cluster and you're not sure how to get that name of cluster, for example, well, as I demonstrated live, like, you just type that MongoDB Atlas project, and then as soon as you hit dot, it pre-populates everything you need. So it's super easy, especially with all the generative AI stuff that's going on now. But I think it's just from a developer perspective, it's good to learn, just good to understand, even without the auto generation, how everything's working. And you can actually get insights of, we created a multi-cloud cluster, tenant cluster. This is the free tier cluster. So if you want to create other either M0, M2, M5 clusters, you can do that. Or any shared tier clusters, you can do that using this tenant cluster. And if you want to learn a little bit more about what does priority mean, what does region name, what does provider name mean, everything is mentioned below. Cluster type. So hopefully that helps. It looks like we're at time, and I don't see any other questions. So once again, my name is Zuhair Ahmed. I'm super excited that you're able to join us today. Any comments, questions, concerns, feel free to reach out. You can find us on our GitHub repo. You can ask questions there. If you have a paid MongoDB Atlas account, you're welcome to create reach an issue there. We also have community forums that you can reach out to us on, which are free to anyone to ask on. And then last but not least, there's the .local events, which are every few weeks. You'll be seeing them. I believe there's one in Chicago that's coming up next month. We're super excited to see folks there.
Yep, Chicago, Sydney, and Tel Aviv are our next three that's coming up. Thank you so much, Zuhair, again for your amazing presentation on Terraform. And thank you everyone for joining our webinar today. Please keep a lookout for an email with the link of this recording and all the links that were shared in the chat today. Thank you, everyone. Have a good rest of your day.
Cool. Thank you. Cheers.